All right, in today's video, guys, we are going to kind of wrap up systems of equations, put it all together, and decide which method do we use. How do you decide when to use graphing, when to use substitution, when to use elimination? This is page 69 in my notebook, so if you are following along with your notes, page 69 in your table of contents, and the title, Systems of Equations, Which Method? I am assuming that you are going to watch this Wednesday, May 6th, and it's 8EE 3.8. So I already wrote it down just to save time. So for those of you taking the notes like you're supposed to be, please pause the video at this time. Write down the notes so that way when I am talking about them and reading through them, you can just follow along instead of trying to, write while I'm talking and not really listen and soak up everything. So write it down, try to comprehend as you're writing, and then listen as we go over it. Okay, so we have learned the three most common used methods to solve a system of equations. Now, just a reminder, system of equations, that's when we give you two or more equations that have the same variables, like x and y, and then they say solve for x, solve for y. So the solution is an ordered pair. Now, the three methods we've gone over: graphing, substitution, and elimination. So we did graphing and substitution last week, and elimination we just did yesterday and the day before. So it is important to know, guys, all three methods will get you the same answer. So, if it does not specify, hey, solve the system by using graphing, if it doesn't specify and tell you which one to use, choose which one makes the most sense given the problem and which one you're most comfortable and confident using. Sorry. So, what was I going to say? Yeah, but it's important to know that all three methods get you the same answer. Okay? So you will get the right answer if you correctly use each method. Now, how to choose which method to use. So how do you choose? Graphing. Okay, so that was the first one we taught you. That's when you graph the two lines, see where they intersect, and that's the solution. If they don't intersect and they're parallel lines, no solution. If they intersect, where they intersect, that's the solution. If they're the same line, then it's obviously infinitely many solutions. So, graphing, I personally only use this method when both equations are given to me in slope-intercept form, which is y equals mx plus b. I think it's really easy to just plot the y-intercept, and then from the y-intercept, use the slope and graph the lines. I also only use this method if graph paper is given. So if graph paper is not given, it's not going to be as accurate to just hand sketch the graph. Also, it's more time consuming. And personally, I don't just graph for fun. So I only use this one if it tells me to, if graph paper is given, and if both equations are in slope-intercept form. Yes, you can graph in standard form, but a lot of times it's not as easy to figure out the x and y intercept, and also, a lot of times, graphing's not the most advantageous form to use because, if they intersect right here, it's hard to know what that fraction's going to be. Substitution. Substitution's best to use when one or both of the equations is already solved for one of the variables. So what does that mean? What that means is basically if we already have one of the equations and it's like x equals or it's y equals. So if we already have one of the variables by itself, then it's easy. You just plug in whatever it says for the variable and solve. So substitution, it's best to use when one or both of the equations basically has a variable by itself. Elimination. Elimination's best to use when both of the equations are in standard form. ax plus by equals c. So, once you have this down, we're going to do some practice problems where you actually see the problems, and we're going to be like, okay, which form should we use and why? I'm just going to flip it over just for neatness purposes. So we're going to do 3 or 4. I'm not going to break it down too much because that's what the other videos are for, teaching you how to do it. So if you aren't confident with it, then go watch those videos. This one's just for basically choosing which method to use. Okay, so the first problem that we're going to do, and obviously the instructions are solve the system of equations using whichever method you'd like, whatever. So example 1 is going to be y equals negative 5x plus 6, y equals 3x minus 2. Okay, so right off the bat, we see our 2 equations. Okay, now both equations, immediately think. Let's look at the other page. Graphing, okay? Are both equations given to us in y equals mx plus b form? Y equals mx plus b, y equals mx plus b. Yes. So if you have graph paper and you like to graph, go for it. Do it with graphing, okay? So sometimes though, there's more than one method that works that might be easy. Okay, let's see about substitution. Best to use when one or both of the variables is solved for. I mean, when one or both of the equations has a variable solved for. These both already have y by itself. So substitution is also easy to use here. We can use graphing or substitution. Elimination, best to use when both equations are in standard form. So both equations are not in standard form. Actually, neither equation is in standard form. They're in slope-intercept form. Now, you could still do elimination, actually, on this equation also. It's just not the most advantageous. So, let's break it down. Here's our graph paper. Let's do this method first. So first we have to draw our y-axis. And our x-axis. Okay, so y, x. Okay, so let's graph the first one. Y equals negative 5x plus 6. Okay, so this is in y equals mx plus b, slope-intercept form. So b, our y-intercept. Y-intercept is 6. So on the y-axis, we go up 6. 1, 2, 3, 4, 5, 6. Put the dot. All right. Now, from that y-intercept, the slope is negative 5. Now, we know slope is rise over run. Okay? Slope is rise over run. And that negative 5, that means rise negative 5, so go down 5. It's over an invisible 1, right 1. So from the from the y-intercept, not from the origin. Go down 5, 1, 2, 3, 4, 5, right 1. Down 5, 1, 2, 3, 4, 5, right 1. Okay, and then you get some type of straight edge. I don't really have a straight edge, so I'm just going to use this paper that's scratch paper for me. And connect the dots as best as you can. Oh, this is not going to be pretty. Okay. See, that's just another thing about graphing. Unless you have a ruler, it's also not as nice. Okay. You know what? I'm a human. That's okay. That's so bad. Alright, so the other equation. Y equals mx plus b. So y-intercept is negative 2, down 2. Slope is 3. So 3 over 1. Rise 3, run 1. Rise 3, so up 3, run 1. Up 3, run 1. Up 3, run 1. Just like up 3, right 1, you also can go down 3, and left one if you want to do more dots. Just going to eyeball it. All right, so they clearly intersect at 1, 1. Okay, so the solution is going to be 1, 1. So by graphing, we know the solution is 1, 1. Okay, so if you like to graph, it's in y equals mx plus b form, go for it. All right. What if you wanted to use substitution? So this was our graphing method. So I'm going to put graphing. And we got our solution. Okay. Now, oh, you guys can even see me write that. Lovely. Okay. Now, let's try solving it with substitution. Okay, so let me just change my pen color just for looking better. Okay, so now we're going to solve it through substitution. Substitution. So, maybe you don't have graph paper. Maybe you personally just don't like graphing. Okay? So then you might solve it with substitution. Substitution, that's when we take one of the expressions and substitute it into the other variable. So these are both already solved for y. They have y by itself. Y equals y is negative 5x plus 6, and y is also 3x minus 2. So I'm going to take this 3x minus 2 and just substitute it. Plug it in for this y, because it says y is this. So just plug it in there. You also could plug this one in down there, whichever one you want. So I'm going to substitute 3x minus 2 into the y up there. So that'll leave me 3x minus 2 equals negative 5x plus 6. Okay? So now we just have an equation with variables on both sides. So draw our line and combine like terms. So we have the x's and then we have the constants. So I'm going to get this negative 5x to the left side. Yes, I could get the 3x to the right side, but I'm going to move this over here because I'm going to keep it positive. So you have to add the 5x to both sides. So 3x's plus 5x's is 8x's. Bring down the negative 2, the equal sign, and bring down the positive 6. Okay? So now we're just going to add 2 to both sides. So we bring down the 8x and the equal sign. 6 plus 2 is 8. Last step is divide both sides by 8. So x equals 1. Okay, so now we have our x solved for, and it's 1. So now we plug that back in to either of the original equations and solve for y. I'm just going to plug it into the second one, because why not? So y equals 3x minus 2. So plug in 1 for x. So y equals 3 times 1 minus 2. Well, 3 times 1 is just 3 minus 2, which equals 1. So y equals 1 and x equals 1. So yet again, it's 1, 1. So both methods gave us the same answer. Now, I personally would not recommend using elimination for this equation, just because substitution seems really easy to me to just plug in the 3x minus 2 up there. Could you use elimination? Yes, you totally could. So I'll show you that. I personally wouldn't do it though. Elimination. So y equals negative 5x plus 6, same problem. Y equals 3x minus 2. So the y's actually are going to eliminate because they both have the same coefficient of 1. So y plus y, does that make it go away? Y plus Y, no, it doesn't. So we have to subtract. Subtract. Okay. Let me do the darker green so you can see. So Y minus Y is 0, equal sign. Negative 5x minus 3x, negative 8x. 6 minus a negative 2. 6 minus a negative 2. So 6 plus 2 is 8. Okay, so now we just have a two-step equation. So you can either add the 8x over there or you can subtract the 8, whichever one you guys see. You guys might see the minusing the 8 since that's just a constant. So subtract 8, subtract 8. 0 minus 8 is negative 8 equals, bring down the negative 8x. Now we have to divide both sides by negative 8 since they're being multiplied. Negative 8 divided by negative 8 is a positive 1 for x. Now, just the same, you plug in 1 for either equation, the original equations for x. Let's say we're going to plug in the second equation, the first equation this time. So, plug in 1 for x. Y equals negative 5 times 1 plus 6. So that equals negative 5 plus 6, which just equals 1. So, this proves that you can use all three forms and you will get the same solution. We used graphing, we used substitution, and we used elimination, and we got 1, 1 for all three forms. For using all three forms. I'm just thinking, because this wasn't my original plan when I filmed this, I was just going to show you those two ways. So yeah, let me just quickly, so this proves to you that you can use all three methods and you will get the same answer no matter which method you use. This one just nicely, you could use all three methods. Now, let's say you had the problem, let's say you had 5x minus 7y equals 58 and y equals negative x plus 2. Okay, so that one, you can see, let me take a drink of my smoothie. That one you can see right off the bat. One of them is in standard form, ax plus by equals c, and one of them is in slope-intercept form, y equals mx plus b. So, yes, you could graph them, okay? This first equation is not going to graph too nicely. So I would not recommend graphing because they're not both in slope-intercept form. They didn't give us graph paper. Substitution. Could we do substitution? Yes, because one of the variables is already solved for. We already have y by itself. So we can just plug this in, substitute in negative x plus 2 for y. Elimination. We recommend using elimination when both equations are basically in standard form, ax plus by equals c. They're not in the same form. So even if they were both in slope-intercept form or a different form, you could easily maybe eliminate. This is not going to be easy to eliminate because this one has x and y on one side and this one they're separated by the equal sign. So the best bet here is to use substitution. So I'm going to repeat, graphing, really only use it if they're both in y equals mx plus b and they give you graph paper. If not, don't even think about it. Then what you do is you're like, okay, I have my problem. Are they both in standard form? No. Okay, so I'm not going to use elimination. Do I have one of the variables solved for? Yes, y is by itself, use substitution. So then you just substitute negative x plus 2 for y. So 5x minus 7 times y, so 7 times negative x plus 2 equals 58. And then you solve it. So you would distribute through the negative 7. Guys, this is a negative 7. You need to include the negative. So 5x negative 7 times negative x plus 7x, negative 7 times positive 2 minus 14 equals 58. Okay? Combine like terms. 5x plus 7x. 12x minus 14 equals 58. Two-step equation. Draw the line. Get this negative 14 over there. So add 14 to both sides. Bring down the 12x. Equal sign. 8, 9, 10, 11, 12. Carry the 1. 5, 6, 7, 72. Divide now because 12 and x are being multiplied. X equals 6. Okay, so that one was just really easy to substitute. And then now all we do is we plug in x equals 6 for one of the original equations. I personally recommend plugging it into the second equation because we have our x and we're trying to find our y now. We don't know what y equals, and we already have y by itself here, so it's going to just solve nicely. But you could plug it back into either one. It's just going to be easier to plug it into this one. So negative x, so negative 6 plus 2. Negative 6 plus 2 is negative 4. And we already have y by itself, so that was just easy. So the solution for this one is 6, negative 4. Okay, so the last example I want to show you is when they give you both equations in standard form. So you guys know that sometimes it's just going to eliminate nicely. Sometimes you might have to multiply it. So let's say we have 3y plus 10x minus 54 equals 0 and 5y minus 2x minus 34 equals 0. Well, first off, is that standard form? ax plus by equals c. It can be, but it's not straightforward standard form. We need to combine our like terms. So for this first equation, actually, I thought I wanted to do this, but now I don't know. Do I want to do this? Yeah, you know what? I'm going to do it. So right off the bat, I would bring the constant to the right side. Combine your like terms. Combine the constants. So add this 54 over there. So that'll become 3y plus 10x equals 54. Because we added 54 to both sides. So it went away from this side, and now it's on the right side. Same for this one. So add 34 to both sides. So that'll leave us with 5y minus 2x equals 34. Okay, so now we have standard form. I know standard form is ax plus by equals c, but we could just switch those. We could just make it 10x plus 3y equals 54 and negative 2x plus 5y equals 34. Now, neither coefficient is the same, so it's not just going to easily cancel out. Like, it would be really clutch right now if these were just both 3y or these were just both 2x, but they're not, so that's when we have to multiply. So you could multiply both of them and be like, I'm going to make these the same. I'm going to make them both 15. Multiply the top equation by 5, multiply the bottom equation by 3. What my mind sees, though, is that this is 10x, and this negative 2x can become a 10x, and then we would only have to multiply one of the equations. So I'm going to go with that one. I'm going to multiply this equation by 5. Because if I multiply this by 5, that's going to become a 10x, negative 10x, and then I can cancel those out. So let me rewrite the first equation down here, just to bring it down. 3y plus 10x equals 54. And then the second one's going to be, so 5 times 5y is 25y. 5 times negative 2x is negative 10x. 5 times 34, I don't know. You can use a calculator. 4 times 5 is 20, 15, 16, 17, 170. Okay, so now we have both x's have the same term in front. Doesn't matter that they're different signs. What's important is that they're the same number. So, do we have to subtract or add? Is 10x plus a negative 10x 0? Yes. So we're going to add them. You just need to do whichever one. Do you add or subtract based on what will cancel out? So, 3y plus 25y is 28y. 10x's plus a negative 10x, so 10 minus 10x, it goes away, equals 54 plus 170. You can use your calculator or just do it in your head or long addition, 224. Okay, now we need to divide both sides by 28. Divide by 28. Y equals 8. You can choose whichever original equation you want to plug this back in for. I'm just going to choose the first one. So 3y plus 10x minus 54 equals 0. Plug in 8 for y. So 3 times 8 plus 10x minus 54 equals 0. 3 times 8, 24. So 24 plus 10x minus 54 equals 0. So now we need to combine like terms on the left side. We have 24 and negative 54. Neither one of those has an x. They're both constants. So 24 minus 54 is negative 30 plus 10x equals 0. Okay, two-step equation. Add 30 to both sides. That cancels out. Add 30. That'll leave us with 10x equals 30. They're being multiplied, so divide by 10. Divide by 10, x equals 3. So our solution, as an ordered pair, x equals 3, y equals 8. So as an ordered pair, it's going to be 3, 8. Now, I'm not going to do it because I did it in all my other videos. But I just want to stress, guys, you can always plug in your ordered pair and solve both equations. And it better work if it's correct. So you could plug in 6 for x, negative 4 for y. 30 plus 28 better equal 58. Negative 4 equals negative 6 plus 2? Yes. If it works, you know you are right. So I hope the practice problems kind of helped clear things up for you, but more than anything, this page is critical to help you really decide which method to use, and will really come in handy on the quiz that you're going to be taking. I hope you guys are having a great day, and yeah, thanks for watching this video.